Hey everyone. Yes, Tin Tams are terrible. Don't understand why you guys eat them, although when I say you guys, I'm Australian now, got my citizenship, so yeah, let's do this. Okay, so microservices make no sense. So I chose this title for two reasons. One, because I thought it might wind a few people up, and that's funny. But two, it's actually how I felt. So about 3 years ago, I started transitioning my back-end work to microservices, and boy, oh boy, everyone had really conflicting opinions about what I should do, what's best practice, what's an anti-pattern. And when I went online for help and I was reading blogs, every single blog seemed to contradict the one I read before it. And I was like, well, I'm so lost, what am I supposed to do? So that's where the talk came from. And hopefully, by the end of this talk, you'll probably see microservices in a little different viewpoint to how you do now. I mean, chances are you're probably already using them. Maybe you don't actually even realize it. I think they're a great tool because what I care about at the end of the day is delivering product for my customers as fast as possible, as well as possible, because, we may be developers, but our job isn't actually to build cool shit or really cool code. It's to deliver product for our end clients, our end users, and that's what's most important. So just a slight warning before we get into the talk. I am going to make some sweeping statements and opinions, and look, while I think they hold up in a lot of circumstances, please take them with a pinch of salt, because obviously in every situation you have to weigh up, your business requirements, your current tech stack, all sort of stuff, and that's why sweeping statements never really work. But, I feel they're a fair estimate, but please keep that in mind because I'm not going to be polite after this point. So when you hear that statement and think, oh, that guy, just remember, look, pinch of salt. What sort of statements, you ask? Well, kind of things like maybe we've had our heads so far at React's R's for the last few years, we forgot about how good it is to deliver performant front-end applications for all our users, not just the people with really great laptops and phones. But yeah, you can ask me about that in Slack channel afterwards if you like. So what are we going to cover? So when should I use microservices? What is serverless? Because that gets thrown around a lot. When should I turn something into a service? How do databases work? And what about service-to-service communication? Because that comes up a lot. It's something you need to know how to do. But yeah, so let's jump into it. So what is a monolith? So a monolith is where all your code and applications sit in one place. You deploy it in one place. Where microservices, you split it up into multiple applications, maybe even spin it up in different places. That's a very, very simplified overview. I'm sure all of you, this being a cloud conference, have some understanding, but that will do as a base. So, if life is simple, don't make it hard, right? Stick with the monolith. If it works for you, if you have no problems, if your end users are happy, who cares? Stick with it, right? In fact, if you're building microservices, you should always start off with a monolith. Unless you're working for a huge company that's already got a distributed system, don't start with distributed systems, because why overcomplicate getting an MVP out? But there's a big cravat here, right? If your back end is simple enough to be in a monolith, why are you building a back end? Just use a back end as a service and get that product out there and start making money, right? A bit of a opinionated opinion, but there you go. If you've got something simple enough for a monolith, don't build an entire back end. No one else other than the developer next to you is going to give you a high five. Your end users don't care. They just want it to work as quick as possible. They want that next feature as quick as possible. So there's some great back end as a services, some I haven't even mentioned there, And while we're at it, stop building APIs for simple CRUD operations. It's a terrible idea. Why did you do that? Back end as a service. So, why would we use microservices? That's a question that comes up a lot. Here's some, bog standard bullet points that tell you some really great things. But that doesn't really help. So I will give you a few reasons why I use them at Climate Clever. So I started Climate Clever 3 years ago, fresh out of owning half of a dev agency, completely scarred from that experience, and somehow got convinced to come work at a startup. And we needed to build the back end as an API because we were always planning to open up the API as well as the apps to our clients. And for any of you who've worked in a startup, you will know that you make sweeping changes out of the blue. Like everything's fine, you come in on Monday, Alex, business requirements have changed, delete all of that functionality, we want this now. Great, thanks. Right, so that's actually why I started using microservices. So I split up our backend into 3 services, which tied in with business logic. I've never done it based on coding logic or coding requirements. It's always based on business logic. So our app kind of, silos itself into 3 sections. Measure, where we track your carbon footprint and, offsets and all this other stuff. We've got audit, where we audit buildings, like appliances and stuff. And then we've got action, where we recommend actions for you to do to reduce your emissions, kind of like Asana, but for, low carbon initiatives. So I split it up into 3 services, and this had one great big benefit, that when on Monday came around and the CEO, my now partner, came in and said, hey, Alex, get rid of this, do this. It was so much easier just to rip a whole service down and spin up something new. They weren't tied to each other. Or when they made breaking changes, like, hey, Alex, we realize we've been doing the carbon calcs wrong. We need to format to this standard. Then it was much easier for me to make those sweeping changes. I could take measure offline, leave audit and action up, and then bring measure back online. So our users got to still use the app while we kept working. It was great. It was absolutely fantastic. So that was the first benefit. And then the second benefit I didn't realize straight away, and this comes down to, I feel like sometimes my end users conspire together to make my life harder. But we would have schools sign up together, and then somehow, for some reason, I don't understand why, all audit their buildings at the same time. And what I mean by this is they gave every kid an iPad. They were like, there you go, there you go. And all the kids would run around the school and add all the rooms and add all the appliances and add all the lights and add every water, electrical, gas appliance they could find, all at the same time. So you've got several schools, all this traffic in the space of a few hours. But microservices were really beneficial here because audit spun up, got bigger to deal with the traffic by itself, wonderful auto-scaling, and all the other services stayed where they were, either offline or really, really small. And this was really beneficial, especially because Measure had so much logic. It was also using an SQL, Microsoft SQL database thing at the time, the licensed version that makes no sense. So, it's great that not spinning up and growing just because a bunch of kids all got together to make my life harder and audited their buildings, right? So that was the second benefit, which, really, really helped our wallet as a startup in the beginning, because, a startup in the beginning, every dollar counts. They're like, hey, can we get free credits, But it didn't matter because it was quite, cost effective. And the final reason, and this is the best reason, I think, testing became easier. Now, testing is a great tool, and you should all be doing it. If any of your bosses ever convince you not to test your code, get a new boss. It's a great thing, right? But the thing about testing that's hard, particularly on the back end, is that the entire infrastructure is all intertwined. You need to know about this service, you need to know about this, you need to know about that. There's so many things you have to mock or fake in the testing environment. But when you split up your backend into microservices, you don't have to think about all those other things. Like if I just spin up Measure and test Measure, I only have to think about the carbon calc database, and I only have to think about the carbon calculations. That's all I have to think about. I don't have to think about Stripe that's involved in billing. I don't have to worry about that. And that makes testing easier, which means if testing is easier, developers embrace it more, and they do more testing, which means your code is less likely to break. So that's another benefit from my experience. And there's a few more on there. So serverless. So serverless comes up a lot when talking about microservices. They're not the same thing. But serverless and microservices go hand in hand. They really are made for each other. And I love serverless. I think it's great. So, there's this really great quote by AJ, owning servers comes with responsibilities. And I love that. So, use serverless. You can launch code without managing servers. The only downside is you now have to manage the AWS console, which is a whole heap of shit. No, seriously, like front-end frameworks have come so far in their documentation, understanding how to use them. I mean, like, look at platforms like Versal and Netlify. Look how easy that is, where AWS is like, yeah, here's a PDF and some stuff, and you figure it out, you know? Like, I reckon they could halve their customer service support team if they just invested in good documentation and great UI. But that's a topic for another time. So anyway, serverless, you know, it's really great. So here's a few different examples. You've got serverless functions, Lambda. You've got ECS and EKS, which is serverless containers. You've got edge computing, such as Netlify edge handlers and Cloudflare workers. A lot of AWS stuff there. I know Azure and Google offer similar services, but I spend most of my time in AWS, so I can't, you know, I'm not going to talk about stuff I've not used. And these are really great, because you can pick and choose what you want to do. Like, you've got a function that's not going to be called all the time. Make it a serverless function, right? It doesn't need to be running. Let's use Lambda. You've got maybe an API that's constantly going to be getting requests, running lots of cron jobs. Let's spin up a serverless container. You know, job done. You want to process data on the edge and not upload massive files to your server. Let's process them using edge computing, right? So there's lots of different capabilities with serverless, and this is where microservices fit in. Because if you build your system using distributed and microservices setup, you can take advantage of the best tool for the job. You know, you're not restricted to throwing everything into an EC2 instance and that having to grow massively. You know, you can take advantages of changes. You know, and that's great, and that's why I love it. Look, I'm a JavaScript engineer, you know, so hate me or love me. I just want to get things out. I want to get things working. I want to use the latest tools. And serverless and microservices work well together. That saying, they do have their, you know, issues. Like, serverless is hard to get it going the first time. You know, when I first started with ECS, I spent 2 weeks trying to get it set up. I got sent this GitHub PDF by one of the AWS engineers that was showing me how to use it. That didn't really help, you know, and I spent 2 weeks spinning up my containers only to watch them shut down 5 minutes later. Turns out I was missing a health endpoint that wasn't mentioned anywhere in the docs whatsoever. But I feel that's AWS's fault, not mine. So, now this comes up a lot. everyone's all like, oh, so I need to learn Kubernetes. You don't need to learn Kubernetes. Fuck Kubernetes. Oh, you actually like that? That's quite funny, because normally when I say that, people get really cross at me. Look, the thing is, if you've got a multi-cloud deployment, so you're deploying to, you know, Azure, AWS, yeah, Kubernetes, you're going to need it. You've got a big, huge, complex setup, you're going to need Kubernetes. But just like I say to you, you shouldn't start off breaking everything down into microservices, you shouldn't start off with Kubernetes. Add it in later. You know, there's tools like Amazon ECS. I just stick a Docker container in there, and it spins up itself. You know, why do I need Kubernetes for that? You know, connect it to the load balancer or the API gateway, off you go, right? Kubernetes is not needed. So if anybody tells you that you need to learn that thing, you don't. Ignore them. So should I turn this into a service? So now you're thinking, okay, you've sold me a little bit on the microservice idea. I'm looking at my back end. Should I separate this part of this code and make it its own microservices? Well, the answer is no. And that's a really great quote by this engineer called Alexander. So it turns out after he created these 3 really great services, he kind of went a bit crazy and turned everything into a microservice and then had to slowly dial that back. Turns out just distributing everything doesn't work and is a really bad choice. So you need to really think carefully about what you turn into a service. Because it does have a knock-on effect. So a really good example of that is we have measure, audit, and action. They're all their own service. They all work really well. But the thing is, we start introducing notifications into the system, such as emails, text messages, push notifications. Now, as a developer, I've been constantly drilled into me that I should not repeat myself, right? So if I implement an email service, I now have to implement it in measure, audit, and action. That's the same code 3 times. That's really bad, right? So notifications becomes its own service, which isn't a bad thing. You know, that is an example of a good service. You know, so now measure, audit, and action can trigger a push notification. Notifications isn't connected to the internet, so it's more secure. It can only be talked to by internal services. But that's why, you really have to be careful about what you turn into a service, because once you start that journey, other things will get turned into a service. Now, that doesn't mean you can't share code between microservices. One of the things I used to hear a lot when I was starting my journey was, oh, you can't share code between services. That's an anti-pattern. It's not an anti-pattern. Have a private library. We've got this really great helper at Climate Clever. It's called API error. And the reason it exists is because I cannot remember what every number of HTTP status codes means. So I created this wonderful helper where you just go API error, throw bad request, or throw unprocessable, or throw unauthorized. So that way you can pass in an error message and it sets the correct HTTP status code. Because, words are so much easier to understand than numbers. So why would I want to code that 3 times? No, private library, share between them, off we go. There's actually this really great blog by Yoni Goldberg, I think I'm pronouncing his name right, that's like a questionnaire about whether you should turn something into a microservice. Absolutely fantastic. He's very opinionated about Node and backends as well. But yeah, give it a read. There's a QR code there for everyone to scan it. I'll just give you a moment. But that's a really good sort of basic questionnaire of whether you should turn something into a microservice. Have you all got the QR code? All good? Right, cool. But then for balance, here is a 5-minute presentation about why monoliths are great. I've muted the link, so if you click on it, it won't play. And that's sort of like a little talk about why monoliths are a good thing. Yes. Interesting. So databases. Okay, so databases. One thing I really struggled with was databases, right? I've got multiple services now. Do they use the same database? And every time I search this question, someone did scan the second QR code. Sorry, I couldn't help myself. I love it. Anyway, so I used to see this diagram a lot, which is absolutely fucking useless, right? They're like, this is your user collection, and this is the collection for orders, and they all have their, it makes no sense, because the thing is, if you had orders, that would be tightly coupled to users, right? You can't have an order without knowing who the fuck actually ordered it, right? So, this example sucks. But they're right, having separate databases for each of your services makes sense, because, if you've got one microservice that needs to access the data in the others, well, then why did you split it up? A really good example at Climate Clever with our measure, audit, and action, they don't share anything. The only thing that they share is something called an entity ID. And that's just a reference to a building, like a school or a business or a home. So they have nothing in common with each other, so it's easy for them to be separate. But, let's say you're working for a startup and you're like, Alex, we can't afford to spin up 3 databases at the same time. What do? Well, just use one database, right? There's nothing wrong with that. No one's going to get cross at you. It's totally fine. And that's what we do at Climate Clever, although I'm about to now finally split one of them off. And now you're like, but Alex, now each microservice can access each other's data. No, they can't. It's called permissions, So what I do is I just set up a username and password for each database. I'm simplifying it a little bit. And that just controls what collections they can access, or for people who use SQL tables, right? It's the same thing. And so that way, the measure service can only access the data that it's allowed to access and audit and so on and so forth. And it keeps the data siloed and secure. And then when it gets more complex, then spin up another database. Never start off complicated, always start off simple. Because you never know, you might not be here in a year's time. The company might go bust. So, why create something really complicated? Keep it simple. Although there are serverless databases now, so, that's an option too. So communication. Now, this is the thing that really stumped me, because I was like, if they need to communicate, why did I split them up? And I was really flummoxed by this. But, like I said, we split them up for a lot of other reasons, like, separation of concerns, testing, costs, all this other stuff that are great benefits, which means you now have to deal with distributed services, which is hard. It is another way of thinking, but it is really great. If you think about tools like Netlify and Versal, I don't even remember how to deploy a website. I know FileZilla was involved, and some other, I don't know. Like I don't know how to SSH into a server anymore. I know I used to spin stuff up on EC2 and something, but like it doesn't matter, right? Like serverless and microservices are here to stay. They're not going anywhere. They're becoming more and more of a thing, right? All the tools you use are distributed, right? So you just got to embrace that way of thinking. So yeah, let's tackle communication. So there's a few different options. You've got an internal REST API between the services. This is very common. It's a good place to start, right? Like once again, if life is simple, don't overcomplicate it, start off small. And we actually started off with internal REST API. It was a great thing to do. No issue with it. Does have some downsides as you start to grow. So the first downside is if one of your servers gets really busy, and then another server gets a request and it has to talk to the busy server, it now becomes slow as well because it's waiting for a response from the busy server. So, it's not true async, I think async's the wrong word, but you know what I mean? Like it has to stop and wait before it can continue. And that's not really the mindset you want when you're building distributed services. The other downside is like documenting and maintaining those endpoints. Oh my God. That's such an effort. I should only have to do that for my end users, not for my development team. So, good place to start, but you will hit limitations. The next solution is message queues. I've not really used them too much, so I'm not going to dive deep into them because I'm a big fan of not talking about what you don't know. But it's kind of like a text message, right? You send a text message out to all your other services. They get a response, stuff like that. Then we've got gRPC, which is used by people like Netflix and Square Payments. So that's kind of like you have a whole load of functions in one service. You register them in the great service directory. Think the phone book, but for your microservices. And then other services can call those functions as if they were in that service itself. Really great option, battle tested, fantastic. And then there's things like event streaming, which I decided to go with at Climate Clever. Event streaming is great. And I use Confluent for that. So there's a link to Confluent there if you want to check it out. It's a great tool. Absolutely love Confluent. So what is Confluent? So it's Apache Kafka, but managed for you, because I tried to spin it on myself on AWS. Way too hard. I've got product to deliver. So I signed up to Confluent, put in my email and password. They gave me some endpoints and a few bits of code. Bam, there we go. It's all integrated. Took me 30 minutes. And I spent 2 days trying to get it spun up on AWS. I got it spun up, but then I couldn't let it communicate in the private staging environment. It's just too much of a nightmare. So once again, serverless, Apache Kafka. So the way this works is, let's say I make an API call to measure, right? Measure registers the bills. Or I make an API, actually, better example. Let's say I make an API call to audit, and I add a light bulb in my house into audit. But I say, hey, like, this is broken, like it's flickering. So what happens is, audit registers that item in the database, all good. But what it does is it sends a message into Confluent. It's like, ooh, broken light bulb. And that goes out into the message queues. And then any other service that's listening can pick that up and do actions on it in real time. So, audit isn't blocked. It's not waiting for a response. All it's waiting for is to make sure its message went in. That's it. Once the message is in, it just carries on its merry way. It doesn't care about anything else. And so then action is listening for broken stuff. It's like, hey, whenever broken stuff happens in audit, I'm going to be listening for that. And it picks that up, and it picks up the user ID, and it creates an action for it. Hey, go fix that broken light, right? Because that's costing you money on your electricity. And it's real time, so it's really fast. The best part about it is if a service goes down and then comes back up, all the messages that it missed get processed. Because Confluent has and Apache Kafka has a cache where it holds on to them for however long you want. The other nice part about it, and once again, this is why I love serverless and distributed systems, because a lot of stuff gets managed for you, which allows me to focus on product. The nice part is, like, if your services scale up, Confluent has an inbuilt way of keeping track of who's had what message, so a message doesn't get processed multiple times. And now people might say to you, Alex, what about the cost of Confluent? It's so expensive. I could spin up an Apache Kafka cluster myself, and it wouldn't cost anywhere near as much. Yeah, but we don't just evaluate things on the cost of it running on the cloud. We evaluate it on time spent for an engineer, customer satisfaction. All these things are really important. So stop trying to build stuff yourself and use great tools, because then you deliver products more quickly. So that's my very brief overview of microservices. If you've not fallen asleep, well done. It is, it's late in the day. You've already had a lot of talks. It's quite a boring subject sometimes. But any questions? Fire away.